Okay, guys, today with me I have Jeff Tantsura, and we will be talking about many things. Just as a high level, let me introduce the topics. We will be talking about IGP, BGP, we will be talking about segment routing, MPLS, PCE, about routing in FAT3s, Rift. There are many questions. So I collected some questions from the network engineering group, which I have, and we will be going through the questions and try to answer each one of them as the time permits. You may not know, some of you may not know Jeff. Can you introduce Jeff so for the especially YouTube audience later on they can follow you, or also how they can reach out to you?
Hey guys, thank you for being here. Thank you for spending your time with me. Jeff, been in networking for almost 30 years. Worked for a very large service provider, built a lot of BGP stuff. Been on vendor side for almost 10 years, Redback Networks, Ericsson. Probably built the best router ever.
7750? What was that?
No, it was Redback, Smartage.
Okay.
But you have to be old enough to remember.
Okay. Also, you are doing a lot of things in IETF especially. Can you just talk about them?
Yeah, so I find it a very important part of my life. I find it important to have things standardized so everybody can use them. And I'm very cautious about being fair, and it's part of my life, as well as just dealing with IETF people who I've been seeing every year, 3 times, probably for the last 15 years. So it's really family.
Actually,
so specifically to
I have a question there. Sorry for interruption, but I have a question. Generally, I wonder, most of those IETF attendees, regular ones especially, is the company sponsoring or they pay from their pocket? How is it?
In most cases, it's company sponsored. It's quite, IETF itself is not expensive. It's $700 used to be less. The travel, the time, hotels, food, and everything. Significant amount of money, and there are a few people have retired and pay for themselves, but it's very uncommon. Usually, it's company sponsored.
Mm-hmm. Okay.
Which brings another point. You need to be able to withstand your company pressure to sell their stuff in IETF, right? So if you just go, obviously, you do what your company told you. If you chair working group, if you are in ISG, so I see Alvaro here, it's not always easy, and you need to be able to be fair to other ideas and be open to say, this idea is better actually than the idea that my company is proposing. Not always easy.
Cool. Are you ready to start?
Yeah, so specifically to IETF, I'm the chair of routing working group, where we start most of the discussions about routing. Then eventually we shift them to another working group where we work on fast convergence, where we work on a lot of YAML models, where we work on new architectures. So all the data center work you see came out of routing working group. We decided to have new working groups to work specifically on Rift.
LSVR, are you talking about?
And LSVR, yes. So before, actually, we've published a draft called Routing in DC Requirement. It was just 0.0, and it expired, but it really led to organization of these new working groups, and it's still available on Obviously, so you can go and see the requirements we put together.
I remember you.
I'll provide you a link afterwards.
Yeah, actually, I have that. In fact, in one of my trainings, I share those requirements because you made a public, I think, video. Maybe IETF YouTube channel. I saw that there was lots of requirements from the fabric point of view as well as the routing protocol point of view. Like fabric should support 50,000 nodes, less than 250 millisecond convergence, etc., or fan out ratios. Lots of requirements was there, especially. And when we check, almost no current routing protocol, as well as even Rift and many other routing protocols, are not satisfying all the requirements, it seems. This would be another great talk. We did just a RFC 7938 talk in real life discussion, but this would be another great talk actually. Now, I want to start the questions and we can start discussing. The first one, Jeff, Are you ready? Let's start the
Absolutely.
questions. So the guy is saying IGP scalability. Why IGP protocols cannot handle millions of prefixes like BGP does? Is it due to pet computation algorithm, which limits the scalability, or something else? So we know that BGP default free zone now around 800,000, going to million, disaggregation, and so many things happening, and BGP can scale. Even internally in the networks, people are sending a couple millions of prefixes to the PEs, etc. Why not IGP for this purpose? Is it for the algorithm like SPF is limiting, or what's happening? Just resource issue? What do you think about it?
So let's start high level. IGPs are there to define nodes and links on the node. There's actually much more stuff that you could use or abuse your IGPs for. BGP on the other side is meant for let you know how to get to particular ISN, right? So the level of abstraction is completely different. And this gives you ability to scale much higher because for all you need to know is you need to have mapping of an IP prefix to ISN and the path to get there. Mm-hmm. And then as you traverse towards your destination, you look up your database and you go towards another IS that is resolved through next hop in the route. So BGP is nothing else than largely distributed database and data structure when you have mapping between prefixes to ISNs and recursive reachability through next hops. Right? Okay. If you look at IGPs on the other side, you need to describe a node. You need to describe every link on the node. You need to describe, in a lot of cases, what these links are capable of. But we are more and more using IGPs to transport data. That's really metadata, right? You could use IGPs to transport segment routing related stuff with regards to how large my MPLS stack can be. There's a lot of OEM information, so latency, delays, all the stuff, it's all fed into IGPs. So looking closer into IGPs, so every device needs to be able to tell other devices about its links. And this really limits the amount of information you can transport because obviously LSPs and LSA are of particular size and can include particular number of links.
Mm-hmm. So we are talking about topology information here, that every router needs to know each and every other device, their connection, and the metric between them. But in the BGP case, of course, we don't need to know entire topology of the internet. We are talking.
You only need to know how to reach your next hop.
Yeah, this is putting significant limits. Okay, what if I would increase? Let's say today my network IGP-wise can handle 10,000 prefixes. And if I would increase my resources, CPU memory on the devices 100 times, can IGP start handling 100 times of those prefixes? So 10,000 prefixes, can it handle million prefixes then?
So let's go back. There are inherent limits to amount of information you can propagate as per node basis. Fundamental property of link state protocols is that LSVB on every device in the same area or level must be the same.
Yeah.
So there's also propagation of the information thing. Mm-hmm. And just SPF is absolutely not a gating factor anymore. So last time I did proper testing for SAS probably 5-6 years ago, we ran SPF for million nodes graph for below 2 milliseconds.
SPF run time.
Yeah, so as you see, you are not gated by the
number of nodes.
SPF itself. I mean, especially on good implementation where you do a lot of caching and multi-threaded, you could do it below 1 millisecond. So computation itself is not a gating factor. What's a gating factor really is amount of updates and frequency of updates. If you multiply them, you get unstable networks that never converge. And that's really a problem in very large data centers. That's why IGPs traditionally perform really badly because of densely connected graph. So you get an update from everybody. And you need to process these updates, you need to schedule them, you need to send and generate new updates because, as you remember, everybody has to know about any change. So this is where limitations are coming from. Besides physical limitation based on particular size of particular attributes, so number of links we can include, number of, not fragmentation, but number of fragments we can include in LSP. So all those imposed limitations that hit you about 30 to 50,000 nodes. But in general, it's really the propagation and frequency and size, right? So again, going back to kind of higher level, IGPs aren't meant to be police. They are meant to distribute information. If you look at BGP is really a policy protocol. So at any point in the network, you could change your policy with regards to distribution. It's native to BGP. In IGPs, if you don't look at hacks implemented by vendors at some point in time, the only place where you can employ any policy is really boundaries. It's your ABR or ASBR. If you're on a single area level, practically you shouldn't be able to do anything because LSDB must be the same. There's disconnect between LSDB on one side and how you do forwarding, so your reads, eventually you'll create routing rules.
So scalability comes with the hierarchy, and hierarchy is either through multi-area OSPF, multi-level ISAS, and all the policy is done at the either L1, L2 routers or ABR, ASBR. So basically what you just said is important for this guy's question. You say SPF, so computation, the algorithm which finds the shortest path is not a limitation, but rate of change in the control plane is a limitation, right? So actually this one also was described in the book which you wrote with Russ. So control plane complexity. It's okay. I think the understandable. We provided answer for this question because we have lots of others. Let's continue with them. Actually, this question is important. Jeff is currently working in an IBM company, Intent-Based Networking, and the question, what exactly IBM's, so Intent-Based Networks, tries to achieve and what machine learning can provide for IBM? Yeah.
Great question. So actually, I have a slide, but I cannot share it. Doesn't matter. So if you look at intent-based networking, the idea is to provide full life cycle. So you express your intent, magic happens, and you have working network. So the problem parts are really intent consumption. So today, if you look at any company who kind of define themselves as intent-based, they all provide kind of sometimes intuitive, sometimes less so, but you need to provide user interface and workflow, which is not really native to intent-based networking. I mean, you start thinking from how you define a service.
Mm-hmm.
So this is first point where machine learning could help, specifically natural language processing. How do you take business concept, how do you take high-level abstraction and convert it into something that could be used to instantiate networking? This is very early. This work doesn't exist today, and personally, I find it very interesting to look into northbound APIs towards an ABN system. So this is one place where machine learning can potentially help. If we look at machine learning in general, usually you see kind of two major things. One is unsupervised learning, so you're looking at data, you try to find something interesting. Another one is supervised data, machine learning, where you know what happened, you know the result, and you try to compute highly probable result based on the previous data. So you reinforce your learning, and every time you're not done correctly, you increase the weight. So this is how you get to the right result. So if we take view of intent-based system, it has a number of phases. It has intent consumption, intent modeling, intent instantiation, and validation. And it's very important to have all these phases built together because intent consumption gives you ability to create right expectations. So for example, if you are building BGP fabric, you know that there are going to be BGP sessions between every node. You know what your next hop are going to look. You know all the semantics, so you don't need unsupervised learning. You know exactly what you're looking for. However, what you don't know, what would it mean if next hop in a route changes from one to another and does it every second, right? So there's a lot of operational states and data that very difficult to understand, especially at scale. In this case, if you can provide post-mortem, so after you figured out what has happened, and your system actually has learned, if I see this 40 event, they mean one particular thing, this is great help for root cause identification. I think this is where machine learning is really going to shine. So it's really a sub-part of intent. It's not a replacement, because you still need the context. You still need the intent, because you reason within the intent. But ability to understand changes at scale, we humans, we are extremely bad at it. So this is where machine learning, I believe, going to shine.
Let me just repeat what I understood. So, by the way, Jeff just described supervised and unsupervised learning, which is the highest, let's say, structures of the machine learning, and then lots of other things like deep learning, etc., comes under this either supervised or unsupervised learning. Supervised learning, what we know, we put into the algorithm, and what we want to know, we can understand. So basically, cat example, we provide lots of cat, dogs, etc. Then ask the algorithm, okay, is this cat? So it can understand from the previous data, but we need to put lots of data. Now my question then, Jeff, we need a lot of data, and how intent-based in the IBM case, how you will provide so much data to the system and then can get some predictive result?
So there's traditional approach of building data lakes. So you get all the data you can, which is tens of terabytes a day, and you try to run some algorithms on top of it, employing techniques of clustering. Okay. So there are many things you could do with it. The question whether it's worth doing it, because now you're paying for storage, for cooling, for whatnot. You also need to provide network, which in this case could be of size of your production network. So if you use out-of-band network, imagine you're building second network just to collect your analytics. On another side, in intent-based system, there's closed loop. So after you define the service, you know exactly what it is. So in this case, you could only focus on data that's important. So for example, counters are kind of abstract data, right? It's important to know anyway, so you do it. However, on itself, the fact that load on your interface change from 10 to 15% is meaningless unless you understand the context. Maybe introduce new service, maybe link went down somewhere really far away, right? So the combination of context that provided by intent consumption and the really limited data consumption in terms of analytics, and then ability to either correlate one event to another or run supervised learning on top of it, I think it's much better, much more realistic approach.
Lots of correlation also can happen. Like, okay, if the, let's say, temperature goes this level and maybe another event, if it happens as well, we will see interface down event. It can understand lots of, after this loss of correlation. In this case, maybe clustering technique like under the unsupervised learning can help, right? So in IBM,
yeah, absolutely.
Yeah.
But so you can absolutely cluster data today and figure out that you see. I have really good slides on it, but you can see that something has happened. For example, interface went down, or the session flagged. So you can actually correlate symptoms to something. But the question is then, is it really significant? If link went down and I have 16 links up, is it significant? Is it going to impact particular customer, particular application? So the context here is fundamental to really identify data as either actionable or just for information, right? And this is where value is coming in. I mean, there's a lot of data points. There are billions of data points out of middle-sized network. The question, what do you do with them? How do you make data actionable?
Okay. So it was nice as well. Just also let me verify the last thing about this. So in IBM case, then we can take the advantage both from supervised as well as unsupervised learning. Is it correct?
Yeah, so I would say supervised is much more natural if you build proper postmortem analysis into your system. So if someone after an event can describe what was the root cause, what were the symptoms, it's very easy to apply supervised learning to this kind of information. So I'll give you a very simple example. Optical vendors, they all preach, we do machine learning now when your power level on optical hits particular level, we know it's broken. Sorry, I knew this for 20 years, right? So I just needed to collect it. However, what machine learning gives me, now I don't need to go into my system test to look when it reached 72%, it's broken. It can actually learn based on past events. If optic of particular type reaches particular thresholds, probably it's broken. So you see, the statistical analysis been for a very long time. We could do this before, but now you can automate this loop and fine-tune it. For example, if it reaches 69%, it's going to break. It's not broken yet, but probably you need to replace it. And this you couldn't do before because there was not an updated
Data.
correlate.
Yeah. Data as well as computation power.
Yeah, I mean, computation power was always there. It was more expensive.
It was expensive, let's say. Yeah. Okay, third question. We are changing the topic to another topic very fast. First we discussed IGP scalability in general. Then we talked about IBN, intent-based networking. Third question is about segment routing. And the question exactly, what do you think about the future of this SRv6, segment routing v6 data plane? Would it increase the adoption of IPv6 in the networks? So what do you think about SRv6 future? So do you think people should invest? And the second part, would it increase the adoption of IPv6 in networks?
So indirectly, it could. If we look at history of SRv6, the idea was great, the implementation perhaps not so. It has become a very expensive technology in terms of ASIC processing, in terms of amount of overhead, and unfortunately, it has become a religious discussion. I mean, it's very poisonous topic, actually, right? Because I would argue that initial implementation, the way extension headers were designed and where data was put in wasn't really optimal. So what we see now, there are some additional proposals on known as SRv6 plus and M, some other. So people are trying to mitigate it, and now it's not discussion about technology anymore. It's a religious discussion. My implementation is better than yours, and mine is bigger than yours, right? So it's a very tough situation in general. Practically, I see the best implementations today done actually on the host. So there's a large provider in Japan, Line. They actually describe how they use SRv6 on the host. They use it in a way VMware would use Geneva. So there's a lot of places that you could put some metadata that describe some particular type of service, particular application, many things. So they're using it such a way that on the application, so endpoints know that SRv6, but the rest of the fabric is just IPv6. And I believe, so in general, kind of keeping complexity at the edge, it's a good idea. So fabric should be simple. I think this is where we will see first applications of SRv6. I know there are like 2 or 3 networks that run today SRv6, probably Softbank, one of them, there's some in Canada, but I would argue that it was more political than technical decision. So,
I think they were preparing together with Clarence. So he was talking about the Softbank deployment, and they did, right?
Yeah, so they did, but there are many things that are unknown about throughput, about what ASIC, I mean, we know what ASIC it runs, but what's inside of this ASIC, probably not what we think it is. So there's significant cost that you incur when you implement it. The question whether your business or additional value that your business would create with this overhead is justifiable. If it is, absolutely. If it's just political discussion, and again, my technology is better than yours, it's pretty bad situation.
So then if you
but in general, yeah.
It's not exactly apple-to-apple comparison, SR-MPLS, SRv6. There are many differences
Absolutely.
for sure. But if you would, just let's say for the transport purpose, if you would compare SR-MPLS, SRv6, what you would say?
So, SR-MPLS, so MPLS is one of the greatest technologies invented. If you think about how it abstracts notion of an IP address, how indirection works, how you scale by putting more labels, it's absolutely great technology.
So this is another religious discussion, definitely. Some people don't love, even hate about MPLS, but MPLS and BGP really great in my opinion as well. Sorry for that.
Yeah, so I think the term MPLS was poisoned by SD1. SD1 had nothing to do with MPLS. SD1 was replacement for a VPN service, right? Not for MPLS. MPLS is encapsulation, not a service. So there's a lot of misunderstanding of what MPLS is. Right? MPLS is encapsulation.
Actually, this question was there as well, and I didn't want to ask, but it's good that you started. MPLS, when we say SD1, is it replacing MPLS, etc.? Please go ahead.
It doesn't. It replaces service provider provided VPNs. They could be done over MPLS, IPsec, pigeons, you name it, right? So I think why people think this way, because the most significant driver for MPLS to become what it is today was replacement of frame relay VPNs, physical VPNs, pretty much, right? So that's why people kind of mix these two terms. But on itself, encapsulation has nothing to do with services you provide over it. So SD1 replaces VPN service layer, not the transport layer. Yeah.
So yeah, of course, the customer.
Back to segment routing.
Exactly. Go ahead.
So
SRv6.
MPLS dataplane is used in SR-MPLS, as we know, and so the pendulum always goes completely away. So on one case, you have all the information in the network. On another case, you remove all the information from the network. And SR-MPLS is this another side of the pendulum. So we removed all the information from the network, right? Only edge knows how to get to another side. It imposes the SR stack, and here you go. So why it's so good? It's very efficient because it's MPLS encapsulated. MPLS structure-wise, how label and how MPLS header looks like, it's very, very efficient. It's greatly designed. So SR-MPLS levers this very, very efficient encapsulation to provide this functionality. In some cases, and I particularly dislike LDP as a protocol. It's a hacky protocol. It has always been problematic. We've been fixing bugs in LDP since it existed. It never fully converged, was always buggy. So replacing it with something better is a completely great idea. LDP was built to be synchronized with IGPs because if you don't have a route for a label binding, you'll black hole, right? So there's so many interdependencies, create so many complexities and bugs in the code. We never fully recovered. There's still problems in LDP. You would be surprised. Been running for 15 years. So replacing it with something better is an amazing idea.
So then
notion of
our last question anyway will be LDP, RSVP, SR, which one, why, etc. Yeah. You are answering, but we will do this discussion there as well. Yes, what he was just talking, there was very important point. Let me just emphasize that IGP LDP synchronization, especially lots of service providers which I know, they have LDP and they have this feature as well. Basically, we have, in order to overcome the black holing, when you have LDP and IGP network, IGP LDP synchronization and LDP session protections. So those two features. This is when we compare the LDP and the segment routing. Immediately segment routing guys, they will tell you when you have LDP, you have to synchronize, and this synchronization or Russ, I think, call it surface, and sometimes I call it protocols should follow each other. Basically, if in case of failure, you have, let's say, IP route, IGP converged, but LDP not yet. So you will see black hole because on that link there should be label as well. So that's why LDP has to wait IGP to converge, and then IGP should update to the neighbors that, okay, I can be used as a transit node again. And this is actually not only for the IGP LDP, it's for the IGP BGP as well. We have, when we use OSPF, maximum metric router LSA, or when we have ISAS, we have overload bit, etc. Exactly, we are trying to do same thing. IGP has to be synchronized with BGP as well. And now, just when we use BGP as a single protocol as IGP in the data centers, we have a BGP graceful shutdown community, very similar to exactly this behavior. You are informing your neighbors that I will go down, don't use me as transit. But when you use with LDP, exactly what Jeff was saying, you need to also make sure there is new protocol now, and this should be synchronized with the IGP. SR, we will describe SR more and more. There are a couple other questions about SR. When we have SR, SR labels in the MPLS data plane case will be advertised within the IGP update, so it's not a separate protocol that you need to synchronize. Sorry, Jeff.
So you reduce this interaction that creates complexity between two different protocols that are distributed. So you realize that every part of distributed system will do same thing at the same time, which is completely unrealistic, right?
Exactly.
So as Orhan said about SR control plane, the seeds and the information about prefix itself is distributed simultaneously. So actually, in this case, you get kind of global synchronization, because at the moment you learn the prefix, you also learn the binding. You know which label to use to get to this prefix, right? Exactly. So you remove level of complexity.
Exactly.
There's another side of this, however. So now we removed all the state. Suddenly we lost multicast, because multicast requires state in order to assure loop-free operations, right? That's why we do RPM. So practically, when you do segment routing, you remove all the state from the network, you cannot do labeled multicast anymore. It's topic for another discussion. We'll probably talk about beer, but in general, there are trade-offs always. You remove information, you lose functionality. Right?
Oh, there is always removing information also. There is always good and bad things about that. When you remove information, we can now converge maybe faster. We can have less complexity. Troubleshooting might be better. But exactly when you remove that information, what you said also as a cons, as a disadvantage, so maybe suboptimal routing, maybe other functionalities will not work, and you need to have a new protocol. Like actually, when we decided let's do this kind of talks and discuss advanced topics, we were talking about beer, and I said this will be a very huge discussion, so definitely we will have extra session. Beer, another good idea. So let me wrap up this question. For the SRv6, you said so far implementation was not good, getting maybe better. Extension header, especially because of the extension header, I think there is compression for the extension header now. We are talking about. What about the security concern with the extension headers?
So, as you probably know, some time ago, we as networking community decided not to use extension headers for source routing, right? Why? It was so insecure, it was so full of holes. Actually, anyone could send you a packet and influence the way it's going to traverse. So everybody stopped producing RFC and everything else. So now, and I think we've been discussing this for the last couple of years, how do you ensure that SRv6 information doesn't leak outside of your domain? How do you make sure that someone who is outside of your domain actually can inject data into your domain? And a lot of these questions are not answered yet. So there's some logical definition of an operational domain, such as an IS or something else. Practically, I think we will, when it gets deployed at scale, we will see same issues as we see today with BGP. Some people just don't care about security. Some people don't care about doing anything about it and will just happy propagate whatever you send them and then blame you.
It seems
So I think that,
like me,
I
you
think
also
that,
scared a little bit about SRv6 at the moment.
yeah, that's we see BGP hijacks every 2 weeks, right?
Yes, actually, we hear every 2 weeks. It's based on the statistics because in one of my trainings also I'm covering RFC 7908, route leaks, 6 type of route leaks, etc., and hijacks, sub-prefix, exact prefix hijacks, etc. Every day is happening. But what we hear when especially famous networks get involved, like Google was there last in 2019, level 3 was there, and big ones happened.
I mean, pretty much everybody large enough not to care, right?
That's right. And security concerns still there and not that much addressed yet, but still we are seeing at least couple production deployment with the SRv6, especially for the service provider. In my opinion, this should be considered very carefully because not only security concern but also vendor interoperability, another thing. Extension header usage, another thing. Header might get very large. That's another concern with the SRv6. But if you have anything last for the SRv6 question, want to say? Otherwise, let's move to another question.
Yeah, so the technology is interesting and promising. We need to find the right balance. So there's a number of overlay technologies that somewhat compete with it. So NSH, there's a number of encapsulations such as GNIF and BX1GP that can provide good placeholders for metadata.
So as you know, with the SRv6, what they advocate that you don't need NSH anymore. With the SRv6,
so
you don't
I would argue you want to keep layers separated. So I actually
because they can carry the metadata as well there, right? They can carry it. So why we need extra another protocol? So let's reduce the complexity. Why we need NSH anymore, etc. By the way, as an IT,
you pack too much functionality into single technology, you ossify it, you make it rigid, you make it complex. That's why it's always better to have separate layers that don't necessarily interact with each other.
Why everything then we are placing in BGP?
Very good question. Kitchen sink.
Okay, let's move on to another question. As you can see, guys, actually, for each and every question, we can make 1 hour at this discussion. But I have to move to next question. It's already like 40 minutes. Don't worry. We will, as our schedule permits, next week, I think next week you are in a trip. We will have another discussions as well, but we will try to find each other. Fourth question we are talking about. Will Rift routing in FAT3s be deployed in the data center networks in production? So I think RFC also published about Rift.
No, we are still in process, but it's been submitted to ISG, so final stages. Final stages,
almost there. But as far as I know, also there is no production deployment for the Rift. What do you think about this?
So standardization and productization are two different things, right? So as of today, there are two known implementations of Rift. One in Juniper, another one by Bruno Reisman, that's Python-based. Discussion about implementation FRR have been going on for a year. I think they're missing some funding. Eventually, I do believe there's going to be FRR implementation.
Just let me put a comma. So FRR here, he doesn't mention about FAT3 route. It's a free range routing.
Yep.
Okay.
So Juniper started to ship Rift about probably 4 or 5 months ago. So it's available on Junos and QFX and probably on MX as well. Knowing the company, they must be a customer that justifies the development. So I believe there are 1, 2, 3 customers who are actually using Rift, because I also seen from standardization perspective, authors coming back and changing things based on operational experience. So someone is running it at scale. Unfortunately, I don't know public reference who does it. I do believe there are customers. Rift, and I'm biased, I'm the working group chair. It's really great protocols, probably one of the most elegant protocols ever invented.
So upstream it is a link state, downstream it is distance vector.
Yeah, but it has very interesting, so it's not a Rift talk, so it has very interesting properties that no other protocol can provide, namely
Shortcuts,
positive and negative disaggregation.
Yes.
Right.
Without actually drawing, it's very hard to explain it. But for example,
So
RFC
we
7938.
could spend 30-40 minutes on Rift another time. I can also invite Tony Chanda, who is dear friend and actually the inventor of Rift.
Yeah. So basically, you believe, and I believe as well, Rift is a very good idea, especially for scalability and this disaggregation. This disaggregation is a concern and shouldn't be done. It says in the 7938 when we use BGP in the massively scaled data center MSDCs, but Rift is addressing this in an elegant way, we can say. But the question, my question here then for the Rift, is Cisco supporting it?
No.
So without Cisco support, do you think?
I don't believe for political reasons Cisco will support it unless they get really large customer beating up with money and saying, unless you implement it,
So do you think without Cisco's support, backing on that, would it go to, very popular protocol level, or what do you think?
So very popular is questionable, right? If you need to solve right problem in a particular way, in some cases, Rift is going to be the only solution. For example, Rift is the first protocol that is schema-based, right? So you want to introduce new functionality, all it takes is really changing the schema, recompiling it. You could be running a new protocol within 20 minutes. No existing protocol allows to do this today. So imagine if you want to provide some additional transport for some metadata that's important for you, and you're innovative and you know what you are doing, Rift is perfect for you. You need a network so Rift, while built for data center, can work in any network that is direction full graph, right? So you always need notion of east, west, north, south for Rift to work. For the rest, it can work anyway and anywhere. Don't forget, it's loop-free per definition. So now your ECMP is becoming really, it doesn't have to be pure. It gives you built-in functionality to provide kind of metric for your band. So you could start load share unaccurately without caring about equality, because Rift is loop-free per definition.
So you are talking about weighted ECMP is supported as well as UCMP as well supported?
Yeah, so it's built into the protocol.
Built in the protocol. And when you just said that, it reminded me another protocol can support arbitrary topologies as well, Ripple. Of course, this is not the question of here, but and lots of also metrics can be used in Ripple as well. Here, from the metric point of view, Rift is not coming with lots of other benefits. Maybe still bandwidth will be used. Still, what else? So not much anyway in the data center networks is requirement. So in case of IoT networks, of course, there will be lots of other requirements if there is a battery node or not, and lots of other things. If it's a ETX value, so reliability value, etc. But here, anyway, we are talking reliable networks and point-to-point connections and so on and so forth, and densely connected networks, data centers. By the way, Rift for the data center particularly. Even I think Tony, when he was presenting, he's specifically saying.
There's some other parts that are of interest, right? Ability, there's a channel for for metadata by using not the classical way when we put all the data into reachability, like in SSSPF. It has separate machinery where you could put data, and it's natively integrating into something like Redis. So you could push any data. You could push Pigeon if you like, but the protocol was designed last 2 years, so a lot of legacy decisions have been completely cut out, and we've learned a lot. So from Ripple guys, actually, we interacted a lot. They contributed a lot to this work. We interacted with Facebook on their stuff. There are some similarities as well. So there's a lot of learning and experience that we put into Rift. But I don't want to hijack this particular discussion to talk about Rift. It would be great to have 30-40 minute discussion to do the medium level introduction for Rift, why it's good. So there's a question why Cisco doesn't support Rift. It's a political decision because Rift is invented and implemented by Juniper. So it's kind of natural for Cisco to say no unless there's really large customer who would come and beat them up. There's a number of alternative solutions. Most popular today is extensions to OSPF and ASIS to reduce flooding. So actually, there are two implementations on Arista and Cisco NXIS. And what it does really, it chooses designated reachability device that removes this full any-to-any distribution of information in the network.
Almost like a mesh group.
Yeah, it's just the difference that mesh group is manual and cumbersome. In the reduced flooding solution, the election of designated forwarder is automatic and done for that. So it's a good solution and it leverages existing ISS implementation.
When it's with the ISAS, I think it's called Open Fabric.
No, Open Fabric is different approach.
But also with the Open Fabric, I think Russ, their company, old companies they were doing, they are trying to simplify the state machine of the ISAS, right?
Correct. So there's also Ross's proposal. However, there's implementation of FRR, but I don't think, actually, I don't know whether anyone is going to implement it. The reduced flooding proposal is widely supported, implemented by Arista and Cisco on NXS. So I assume we will see deployments of it, and it actually solves most of the scale problems in data center. However, it's still ISIS for all the good and bad things, right? So you cannot do what you can do, for example.
Okay, next question. How do you understand if a new technology requires hardware change on the devices?
Yeah, so if you look at ASIC, most ASIC have reasonably fixed pipelines, and they can look up particular amount of bits every time they receive the packet. So this number one is information I'm looking for within the depth of my lookup. Because if it's not, now I need to either grab more data when it comes in, or I need to do double lookups. So double lookups, obviously, you lose half, not half, 30% of your performance. If you need to get more data, you can do less packets in particular time. So number one is how deep is data you're looking for. That's why SRv6 is problematic. That's why Geneva is problematic. That's why anything that requires looking deep is painful. Even more painful where data is not fixed. Because, for example, if I look for VPLS label, I know exactly my offsets. So I can skip data that's not relevant and say, start looking after byte 32. So this operation is almost free. If I need to say, look after byte 32, read the data, which tells you where to look further, suddenly you lost 30% of your performance.
Because so you do two times
lookup. Make sure the data you're looking for is within your depth of your microcode pipeline.
Okay.
Number two, so your pipeline allows you a particular number of processes. Yeah, I think we could discuss something like, I don't know, Jericho maybe at some point in time. But if you need more processing or more lookups than your pipeline allows on number of stages in your ASIC, it will require you to recirculate packet and inject it somewhere in the middle or in the beginning of your pipeline. What it means, you suddenly cut the bandwidth available in the pipeline in half. So this is kind of very basic considerations when you start looking into new technologies.
Okay.
Another thing is control plane. By now, probably not a problem we see most vendors putting really powerful CPUs, at least 16 gig of memory, if not more. So, I mean, there's much more processing that you ever really need steady network. So it's really the ASIC. And not to forget, ASICs are hot. You need to cool them down, and routers, especially switches, are limited size. So the more processing you do, the more heat you dissipate, the more difficult is it to cool them down. And if you look at something like Broadcom, if it requires more processing, power consumption goes skyrocket. And it's a very serious consideration for smaller devices.
Yeah. Okay, let's move on to another question. Can you talk about control plane and data plane complexity and scalability point of view? For example, VPLS and EVPN. One of them control plane operation, another is data plane. Which one would be considered more complex and which one is more scalable and why? So VPLS and EVPN.
From implementation perspective, EVPN is probably one of the most complex technologies we've ever invented, because now we are bringing together routing, bridging, and labels. So if you look at any modern router, it has stuff that does bridging, it has stuff that does BGP, it has stuff that does VPLS. All of them are interdependent. So the complexity of implementation, and actually I co-designed for implementation on Ericsson router, is huge. The amount of work you need to put just to make it work is huge. VPLS, on the other side, is very simple technology. You get a packet, you advertise. So in point-to-point links, it's even more simpler. Whatever you get on one side, you spit out on another, right? So, you just need to negotiate right parameters. You need to make sure that your pseudo-wire, your pipe between two sides, aligns MTUs, aligns some information, so you know you actually cross-connect right thing to right thing. So I would say it's more management plane than control, even though we do it over LDP or BGP. In VPLS case, we are really mimicking layer 2 switch. With all the things, if you want resiliency, you cannot. You need spanning tree to remove loops if you do something at the edge. So I would say it was a good thing to kind of introduce VPLS, VPWS, because we needed to go on converged backbone over VPLS. From technology perspective, it was still more bridging than anything else. So if we go to VPN, and we've been thinking about putting MAC addresses in BGP for a very long time. So EVPN came up as a replacement of VPLS and really unification, because if you remember, we had two non-interworking technologies in the industry. We had a Martini solution with pseudo-wires, we had a Compella solution with BGP, and then we had a kind of hybrid with Martini pseudo-wires and BGP auto-discovery. So none of the stuff really interrupt.
I think the interworking node we needed, so the node which understands both LDP-based VPLS as well as BGP-based VPLS.
So EVPN was the technology that would take BGP control planes that were used in the Compella solution and provide also functionality while removing pseudo-wires to kind of really unify the technology. So this is how EVPN came to be. It was really replacement, better VPLS. On separate side, data center technology was evolving. VXLAN became de facto standard. Overlay technology, and then people figured out, surprisingly, there's no control plane. You still need the controller to push all this information down, which doesn't scale since you synchronize and centralize all the operations. So I would say VXLAN VPN today is completely ubiquitous. This is pretty much the only way people deploy today if you use overlays. And this is really what's driving most of VPN today. So large service providers, Verizon, Comcast, and such, I think they all deploy VPN for service provider to replace VPLS to provide point-to-point circuits. But what's really driving is the data center side. There are extensions for Geneve, for anything else. It's so easy for BGP to implement those extensions on top of a VPN, because we finally went into separate route types that do different things, right?
IETF actually comes with the Geneve for the overlays, but do you know any production deployment for Geneva?
So NSXT is, so there are probably thousands of network running Geneva today.
But not specifically configuring Geneva, etc., right? No tunnels, etc.
No. So from fabric perspective, it's a PUDP. However, the encapsulation is Geneva. If you look at ASIC vendors, so Innovium, Barefoot, actually System 2, they can implement some subset of Geneva, which goes back to exactly your question before. What do we need from hardware to support it? So Geneva can, or actually does support variable length things inside of it, which makes hardware support very, very complicated if you want to use them. On another side, if you look at how VMware is using Geneva, they're introducing new options, new metadata, they're transporting so much stuff within it all the time, right? And since it's completely agnostic to fabric, it's only limited to VMware because it's end-to-end or edge-to-edge, they can do it without really caring about what fabric is doing. So, and this is where kind of synchronization becomes complex because VMware wants to innovate at speed of VMware. However, if you bring all the ecosystem of switching vendors and all the other stuff on top, you're going into 3-4 year cycle, which is ASIC release cycle, right? So that's why we don't really see ASIC implementation today, but it's being deployed. It's reasonably good technology. The EVPN extensions for Geneva are solid and coming. But I would like to come back to your question about complexity and VPLS RCWS. So what we did in EVPN, we separated distribution of reachability from learning process. So the learning is still data plane when you receive an
learning at the attachment circuit side. Attachment circuit side data plane, but learning still on the control plane inside the backbone.
Packet, when you extract all the information you need, you distribute it in BGP. And so you completely decouple two operations and they don't have to be synchronous, they're actually asynchronous. So the kind of what we envisioned, actually we did it in Ericsson. I don't know what they do now, but we completely decoupled instantiation of forwarding entries from BGP information. Because if you look from router perspective, amount of BGP routes you can hold today is above 100 million routes, right? No problem. Probably 500 million routes is possible to, given amount of memory in good implementation. So your limitation is always your forwarding plane, capacity of your ASIC, memory on the ASIC, TCOM, and stuff. So EVPN gives you ability to decouple stuff you learn in control plane versus what needs to be in data plane. For example, if you learn MAC address, but there's no traffic that's going towards or from this MAC address, it has nothing to do with forwarding plane. So it creates complexity in implementation, but it gives the ability to scale to really absolutely huge numbers to address IoT, something that was unknown before in terms of scale.
Why you say if we know the MAC address, but not in the forwarding plane, if there is no traffic, so some forwarding table architectures may allow that MAC address to be inside the forwarding plane as well, right?
So I'm not sure what Juniper is doing. I know Cisco fully synchronizes control and data plane. So anytime you learn MAC address, it's pushed in the forwarding plane. Yeah. What we did at Ericsson, however, is when you learn MAC address in control plane, but no one is sending packets, we would keep it in BGP only.
So it would what you do then?
Control plane.
And this decoupling actually would help for your BGP peak as well.
Yeah, so you scale on the control plane, which is much easier to scale than your forwarding plane, right?
Of course, and also since there is no one-to-one correlation, you have recursive lookup in the hardware in the forwarding table, so it would help for the BGP peak prefix independent convergence operation because you have hierarchical FIP.
Yeah, so I mean it's completely different point, but it helps a lot of things. It helps you to converge faster. It helps you to do things that BGP is really good at. So distributing huge amount of information, but you don't need to synchronize it forwarding. Because practically, when you think about large amount of routes, if those routes are in your BGP RIP and advertised to your peers, but they are not in your forwarding plane, when you receive the packet from your peer, but it's not in your forwarding, what do? You drop, right?
So it's kind of like a selective RIP download, I think.
Yeah, that's exactly the same thing.
Selective
More
RIP.
complex because now you need to track every MAC address. You need to synchronize what's going on in forwarding versus BGP. So there's really large complexity in implementation.
It's like what you do there is out of path route reflector, because you don't have to put if the route reflector is offline, so out of the path, you don't have to put the prefixes in the forwarding table, but it has to be in the control plane. So good.
In a way, but so EVPN can scale if built right pretty much indefinitely. And I mean, it's a completely different approach than VPLS. And this is how you really scale your network. You decouple different layers. So you just decouple physical layer that has very rigid constraints because of size from the control plane that given amount of memory can scale to absolutely huge numbers.
So just from this aspect, let's say, VPLS is data plane learning, and there is pseudo wire with both LDP and BGP based VPLS, and EVPN there is no pseudo wire, just very high level, and we are advertising MAC addresses over BGP control plane. So just from this aspect, data plane learning, let's say same network, millions prefix, let's say million MAC addresses we are talking about, 1 million. So VPLS, data plane learnings, all the pseudo wire we are sending, BGP, EVPN, BGP control plane, just from this aspect, carrying over pseudo wire versus BGP, okay? Would it be compared somehow, carrying via pseudo wire versus just without pseudo wire using BGP control plane? Can you compare them from any aspect?
Yeah, so in VPLS, if we take classical approach, so it was pseudo wires, the state is always one-to-one. So every time there's new MAC address, you cannot really aggregate states. You can provide indirection. We did do something. It was kind of, let's not call it too installed. With BGP-based advertisement, now we can do erasing. So you could use hierarchy or indirection in control plane to say, I've got million MAC addresses, but I know they all live under particular next hop or P router connected to it. Mm-hmm. So I don't need to go and withdraw prefix by prefix, so MAC address by MAC address. It's enough to withdraw once. So mass withdrawal is a huge thing. Yeah. And it took years to implement it in VPLS, and it wasn't really implemented correctly. But it's there. With regards to load sharing, you don't need spanning tree anymore. What you need to know is that MAC address is connected more than to the one device, right? So we call it ESI load sharing.
So you are saying from the attachment circuit point of view, it can be multi-home to 2 PE, so active flow-based load balancer.
Or 2 or 5 or 10, right?
Yeah.
As long as you advertise same die and the remote and is capable of load sharing, now you got full load sharing across every path available.
Yeah.
So there are many nice features. And it's kind of natural because the industry, when we started doing EVPN, was in a very different state than VPLS. Yeah.
So BGP itself is solving these data plane loop issues like BGP split, horizon label, etc. Again, this is not the EVPN talk. Hopefully with Jeff, we will do lots of other talks. It could be one of them, EVPN. Next question. By the way, we have over 1 hour now. But let's take another question as well and then decide if we will continue. Do you think BGP, this is very religious discussion, BGP can be, should be, and will be replaced with any other protocol for the global internet?
Yeah, so people often blame BGP for being bad protocol, but I would direct you to Ivan's claims on this. It's not the protocol. Protocol is designed really, really well. It's the people who use it. So before probably 2 years ago, there was no real understanding of what incorrect information could do to you, right? Because okay, so what? I have a longer path or something. Now with hijacking of BGP, doing some stuff to DNS, suddenly you can make money, and a lot of money.
Or
and you could see what was
steal the money
from AWS
or steal the money, Bitcoin
suddenly,
attack.
Yeah. So suddenly people take it more seriously, and RPKI, which is a technology that has been developed long time ago, to at least being able to say, I got the stuff from you, and I can actually validate that this is correct stuff, is finally being deployed. Thanks to Job Snyders and few more people who really relentlessly go around the world and pushing implementations. We see new implementations, and I'm not talking about vendors. Vendor implemented RPKI a long time ago. I'm talking about large networks that are doing RPKI I see every day. So
couple days ago, I think 2-3 days ago, another tier 1 just announced, Telia, that they started both for their customers as well as SF settlement-free connections. Yeah.
So I truly believe that 2-3 years from now, if you want to peer with me and you don't support it, I will tell you, you know what? We are not peering. I don't trust you.
It can be, you say it can be peering requirement.
Absolutely so. And what you see here is that, so we've got all the support in protocol we need. It's really a layer 8 problem. So you need to train people and to finally realize that security is important. If not for you, for your customers, go and do something about it, invest in it. So from scale perspective, I don't think BGP needs to be replaced anytime soon. So to my old memory, when we implemented read filtering in Redback, so when we could keep routes in BGP but not push them into FIP, we could hit 150 million routes with no problems. Think about the number. And it was 7-8 years ago. So given today's amount of memory, amount of CPU, and optimization in BGP code, more and more caching, more and more using many cores, better multi-threading. I don't think from scalability perspective we need to...
I don't think it is for the scalability, Jeff. Also, you described the security point of view, but BGP inherently just trust-based, and people are pushing RPKI. We have also RFC for the BGP sec, but because lots of resource issue end-to-end PET, because it's a PET validation protocol anyway. But RPKI, we are seeing now they are rejecting the invalids, etc. That's fine, but still it will be, in my opinion, maybe another 10-15 years, maybe forever. This adoption is very slow. As far as I know, it's much lower than IRR, RPKI compared to IRR, I am saying, and less than 30% of the default free zone anyway is just currently RPKI deployed. So we have ROAS basically for the prefixes. Less than 30%.
But the important point is not for everybody, for all 40,000.
Yes, you are right.
But to implement RPKI, it's really the core, what we call default free zone plus the cloud providers implement it. You cover 95% of the cases.
Right.
And then if you have 5% left, it's probably not worth financially to even deal with it. So the attack vector will move away to somewhere else from BGP.
Right, that's true. And
there
also
are proposals to use additional cryptography, to use something like distributed security. It's all possible, but the question is, again, it's additional complexity, and now you need to synchronize internal system state to external system state, so it's all possible. The question, where is the kind of golden middle that you're still flexible while secure?
Yeah, my take on this, BGP, can it be replaced? Yes, anything can be done. Should it be? No, people have more other priorities than replacing BGP. Everybody has more, priority things like IETF guys there, vendors, everyone. They have their priority. Think about IPv4 versus IPv6. Why people are buying from IPv4 market? Why not they are deploying any transition mechanisms, etc., or just native IPv6? Another one, what was that? Will be replaced? I don't think it will be replaced with anything. But those who probably think should we replace, maybe two things comes to my mind. BGP wedges, one of them. So we have an RFC for the BGP wedges as well. I have my intent, you have your intent. Of course, our business intent may not be just aligned, and this creates some issues. And in the BGP wedges RFC, you can see maybe one of them to overcome this. Another one, BGP, don't take many things into an account. Is this expensive link, or is this reliable link if there is a packet loss, or there is not such a thing. You have either outbound local pref, which your business intent again, and inbound not much option than community. In fact, even ASP prepending, because some models like Go or export model, etc., people they prefer customer link over their peers and transit and so on and so forth. That's why, in my opinion, yes, it will not be replaced, at least until we retire. It shouldn't be replaced anyway. It's solving a lot of, as just Jeff said, scalability point of view, and scalability is must for the global internet. We are talking million prefix almost now, and can it be replaced? Anything can be done anyway in theory, right? But
yes, I don't think there's enough incentives to change it, and it's really working. It's well-designed protocol.
It's never converged, but it's working. Yes.
Hey, this is life.
Okay.
A lot of things don't converge in life.
Another question. Do you think should we continue the question? You have time?
Let's do one more maybe on SRPC, for example.
Okay, so then one more question. Then we have many other questions. Hopefully, once we have time, another day, another session, we can talk. Last question about PCE. Its significance in segment routing enabled network, PCE, path computation element. SR deployment without PCE, is it equal to LDP underlay? So let's talk about it.
Absolutely. So if you cannot compute a path throughout your network, you rely on your IGP of computing shortest path. So if there's no entities that can compute the path and configure it, you will be using really labels associated with next hop. I mean, if you're doing VPN, for example, right? So yeah, and I think it's a very good replacement for LDP. I mean, if you have a choice, don't deploy LDP today. Unless you need to do multicast, then it's very different discussion, because MLDP is actually good technology, especially in Band 1. And I always like it.
Okay, now the good question coming from me then. Okay, MLDP, for the multicast point of view, MLDP, and you will also have for the unicast purpose LDP versus, let's say, beer, because when you have beer within the explicit replication, you don't need to have LDP. So beer versus, okay, let's say SR plus Rosengieri. Rosengieri, what do you think?
So hopefully Jerry multicast is dead.
Okay, so Rosengieri he don't like.
Beer is a great technology, however,
hardware.
Why couldn't we do exactly? So beer requires replication, so your lookup is completely different, right? Because now you need to count bits and see who is interested, who is not. That's why it actually took much longer to build hardware that can support beer versus control plane and high definition, which we finished 2 years ago. So I truly believe beer is going to be successful for anything that requires multicast. We see huge interest in financials. They're building applications that are doing beer. I mean, it's all happening. I don't think there's way back. Beer has nothing to do with segment routing, so there are not two technologies that work. They could work like independently, shift in the night, but It's not one of them, right?
So
segment routing with any other multicast technology, absolutely, but you end up with two technologies, right? You need to manage two technologies. You need to have people trained to support both with all the consequences.
Sure, but when I was saying
What's
SR,
important, I think, here again is to find the right balance between doing everything twice versus trying to push everything into single bucket, and when it inevitably fails, you lose everything.
so when I say SR, I give generally analogy with the beer. What SR does for the LDP, so it removes LDP requirement, and the labels are advertised within the IGP. Same thing for multicast beer is doing. So it removes the protocol requirement like PIM, protocol independent multicast, and it also sends the updates within the IGP. So IGP now carries many information, not only SR, but also beer. Here would be another good idea for our
So it's
maybe one of the
BGP in other words, right?
yeah, it actually why we didn't use BGP for that, right?
You could.
Yeah, I think it was a not nice but great discussion. To be honest, it's already 75 minutes. Hopefully, the audience when they watch, if you guys see this one valuable, you know now Jeff. Probably already you knew him. Please write in the comment section. So your questions for the upcoming session also you can type. You can reach out. Jeff is mostly using, I think, LinkedIn, like me.
Yeah.
I am using also. We have you have Twitter handle as well. Yeah.
Yeah, I do.
So you just share your Twitter handle as well. Maybe some people are just.
It's Tantsura. It's very easy.
There might be some single homed guys, so networkers here just using Twitter. So that's why I am also on Twitter, but mostly using LinkedIn. You can reach out to us. So you can type your questions on YouTube channel or under this video, and I can collect them. And in the next discussion, also we can discuss those questions. And if you like this video, please push the like button and subscribe also to the channel with Jeff and with the other guys who I really believe that they know what they are talking about very deeply. We will continue to do this kind of discussion. Hope you liked it. Thanks a lot, Jeff, for today, and hope to see you again.
Thanks, everyone. It was my pleasure. And let's plan maybe in 2-3 weeks to at least finish this list of questions that we had and start doing new ones.
Let's weigh the questions.
Have a good weekend.
You too.